What if the Milky Way, our grand spiraling island of stars, was nothing more than a dust particle inside something hundreds of times larger? In 2022, astronomers using a radio telescope array in Europe spotted something that defied expectations. It wasn't a single glowing galaxy, but a pair of colossal lobes of radio energy stretching across space for 16.3 million light-years. They named it Alcyonius, after a mythic giant from Greek legend. To put that into perspective, the Milky Way is about 100,000 light-years across. Alcyonius is 160 times larger. If our entire galaxy fit inside one pixel, Alcyonius would fill the screen. The discovery came from LOFAR, the Low Frequency Array, a network of more than 20,000 radio antennas spread across Europe. It listens to the universe in frequencies too low for human ears, capturing the deep hum of ancient cosmic activity. While optical telescopes show galaxies in visible light, radio arrays reveal their invisible side, jets of charged particles launched by supermassive black holes. These jets can stretch for millions of light-years, sculpting enormous structures called radio lobes. At the heart of Alcyonius is a typical elliptical galaxy, a giant swarm of old stars surrounding a supermassive black hole. What makes it extraordinary is not its core, but what surrounds it, an aura of radio light so vast it dwarfs anything else we've found. When researchers first saw it, they thought it had to be a mistake. No known process was supposed to create a structure so large and so faint at the same time. But after careful checks, they realized the signal was real, a fossil of cosmic energy from a black hole that once blazed with power. These lobes aren't made of stars or gas, but of plasma. Electrons spiraling along magnetic fields at near-light speed, emitting radio waves. They act like cosmic billboards, marking where a black hole once pumped energy into space for hundreds of millions of years. The two lobes of Alcyonius span over 160 times the diameter of the Milky Way. Each lobe extends for 8 million light-years from the galaxy's center. And yet, the galaxy itself, the visible part, is barely a dot in the middle. This discovery matters because it redefines what we mean by galaxy size. For decades, the record belonged to IC 1101, a supergiant elliptical galaxy about 4 million light-years wide. But Alcyonius is something else entirely. A cosmic structure so large it blurs the line between a galaxy and a galactic ecosystem. So how do you measure something this vast? Astronomers don't measure it by light from stars, but by its radio emission footprint, the area where radio waves still shine brighter than background noise. That signal defines the outer edges of Alcyonius's lobes. What's even more interesting is that Alcyonius lives in a quiet neighborhood of the universe. No dense cluster to feed it, no violent mergers. It's a gentle giant, grown slowly over billions of years through steady jets of energy rather than chaos. That makes it a perfect laboratory for understanding how massive galaxies evolve without constant collisions. It's like finding a mountain that grew alone in the middle of an ocean. The team that found it, led by Martin Oey of Leiden University, used a clever technique called stacked radio mapping. By combining many weak signals over large areas, they uncovered patterns too faint for individual telescopes to see. What they saw was stunning. A perfectly balanced pair of lobes, each spanning millions of light-years, aligned like butterfly wings across the cosmos. Alcyonius sits roughly 3 billion light-years from Earth. That means its light, and its radio waves, started their journey before our solar system even existed. In astronomical terms, we're seeing a ghost from the past, a record of activity that ended billions of years ago, but still glows faintly across the void. So, what made this galaxy so large? The answer may lie in its black hole, a colossus with billions of solar masses, slowly feeding on gas and dust and launching jets that shape the space around it. Those jets blast particles into intergalactic space, inflating lobes like balloons over time. Even after the central engine goes quiet, the lobes remain, radiating faintly for hundreds of millions of years. Alcyonius is the largest we've found so far, but that might only be because it's one of the few we can actually see. There could be even bigger radio galaxies lurking in regions too distant or too faint for our current instruments. When we talk about large galaxies, it's easy to forget what that really means. The Milky Way holds about 200 billion stars, stretching 100,000 light-years across. IC1101, once thought to be the largest, spans around 4 million light-years. But Alcyonius? It dwarfs them all, over 16 million light-years from end to end. If you could travel at light speed, it would take you 16 million years just to cross it once. That's longer than mammals have existed on Earth. Yet Alcyonius isn't unusually massive in stars. Its greatness comes from its radio lobes, enormous clouds of plasma inflated by jets from a central black hole. Think of them as cosmic footprints of energy, left behind after eons of quiet growth. This makes Alcyonius a radio galaxy, part of a rare class that includes Hercules A and Cygnus A. But unlike those violent monsters, Alcyonius is subtle, faint, stable, and ancient. Its sheer size suggests it's been expanding for hundreds of millions of years in a calm, low-density region of space. That environment may be the secret. Without nearby clusters or strong magnetic turbulence, the lobes could drift freely, stretching farther than any we've ever seen. It's a reminder that not all giants are born from violence. Some grow through patience, steady feeding by a supermassive black hole that occasionally reignites and releases more energy. Each cycle inflates the lobes a little more, like breaths of a sleeping giant. Over cosmic time, those breaths build the largest known galactic structure ever recorded. Could there be larger ones hiding in the dark? Almost certainly. Astronomers believe that with upcoming instruments like the Square Kilometer Array, SKA, we'll uncover entire populations of radio giants that make Alcyonius look ordinary. These discoveries don't just measure size, they test our understanding of how galaxies evolve, how black holes feed, and how magnetic fields shape the universe. Because if Alcyonius can exist, what else is possible? Could there be even older, quieter relics, radio ghosts the size of galaxy clusters, still glowing from a time when the universe was half its current age? For now, Alcyonius stands as a symbol of scale, the boundary of what we can detect. It reminds us that the universe hides its extremes in silence, not spectacle. And somewhere out there, beyond the range of our telescopes, larger giants may still be growing, unseen, unheard, waiting for us to listen. Alcyonius may be the largest galaxy we've ever found, but it's probably not the largest that exists. The universe is vast beyond measure, and our telescopes only reveal the brightest fragments of its story. For every galaxy we see, there could be thousands hiding just beyond our current reach. Our cosmic horizon acts like a moving frontier. As technology advances, with instruments like the Square Kilometer Array, Euclid, and James Webb, we're pushing that frontier outward, one photon at a time. Each discovery stretches not only the map of the universe, but the limits of human understanding. Alcyonius reminds us of something humbling. Size in the universe doesn't always mean power. Its colossal lobes are quiet, ancient, and fading, ghosts of energy that once roared across intergalactic space. Yet even in their silence, they carry the history of cosmic evolution, written in radiolight. That story began nearly 3 billion years ago, when a supermassive black hole in the heart of Alcyonius started releasing twin jets of plasma. Those jets carved their mark into space itself, inflating 2 cosmic clouds that kept drifting and expanding long after the black hole quieted down. Even now, those lobes are still visible, an afterimage of creation stretched across 16 million light-years. They tell us that the universe remembers everything, every burst of energy, every dying star, every whisper of radiation. When we look at Alcyonius, we're not just seeing distance, we're seeing time. Light from its edges began traveling toward us before Earth's first multicellular life appeared. What we see today is a postcard from a younger cosmos, long before our sun existed. And as we keep exploring, we'll likely find even more colossal structures, invisible webs of plasma connecting entire clusters, and galaxies so old that their light has barely survived the journey here. Somewhere out there may be another Alcyonius, even bigger, even fainter, waiting for us to tune into the right frequency. The universe hides its wonders, not in brightness, but in patience. Every discovery, every telescope upgrade, every faint signal we decode, it's all part of one human story. Our relentless attempt to understand where we came from and how big everything really is. Alcyonius doesn't just show us how large galaxies can grow, it shows how small we still are and how much is left to find. In a universe of nearly endless size, Curiosity remains our most powerful tool. We might never reach these giants, but we can still understand them, photon by photon, signal by signal. And maybe that's what makes astronomy so human. We're explorers who navigate not oceans, but time and light. So, next time you look up at the night sky, remember, every star, every dot, every faint glimmer could be part of a galaxy millions of times larger than ours, shining quietly at the edge of visibility. If this journey through the universe's giants inspired you, make sure to subscribe for more science-based explorations. Each week, we dive deeper into the mysteries of space, one fact, one discovery, one photon at a time.